Hey everybody, it's Grace here. Welcome to lesson 14, and today we're going to be covering factorials. All right, so before we start, I want to briefly introduce the concept of factorials to anybody who isn't familiar with them. So normally, we want the factorial of some number, let's say n, and we denote factorial by an exclamation mark. So this means n factorial. And now what this is equivalent to is 1 times 2 times 3 times blah, 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 all the way to n. So basically, n factorial is just the product of all the numbers from 1 to n. So here's a couple examples. Let's say I want 1 factorial. Let's start simple. Then this is just equal to 1. And then let's use a slightly bigger example. For instance, we may have 5 factorial. Now this is equal to 1 times 2 times 3 times 4 times 5. Multiply all this up and you will get 120. Okay, so once you've made sure you understand this concept, let's go ahead and get started with the programming. All right. So we're going to start simple and write a program that calculates n factorial. And this is basically what we just discussed. N factorial is just a product of all numbers from 1 to n. So now we just want to implement that idea into a program. All right, so let's head to Replit and create a new program for this. I'm going to title mine Factorials. And then proceed with the necessary setup, setting up the scanner and creating a scanner. All right, so let's first read in the number n. And we're going to store that in an integer variable. All right, now we have n. We want to calculate the product of numbers from 1 to n. So we'll be going from 1, 2, 3, 4, blah, 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 all the way to n. Now, if n were a small number or some number that we know, so instead of reading it in, let's say n is 5, and then we just want to calculate n factorial. Well, it's pretty easy. I'm going to call it n fact, short for n factorial. We can just put the expression and assign it to the value of n factorial. So that'll be 1 times 2 times 3 times 4 times 5. And so yeah, this works fine if you know what n is. But here we don't know what n is. And we want to do this repetitive task where we're adding one number that's greater than the last one. So think about all the concepts we've learned so far in this class and ask yourself what might be a good way to go about calculating n factorial. take a few seconds. All right, if you thought of loops like a for loop or a while loop, then you are absolutely correct. Here we want to be multiplying numbers n times basically. And so this is a repetitive task, and then that should remind us of a loop. A loop can do this repetitive task for us. So, we have a for loop and a while loop. We're going to start, let's try both methods. Let's first start by using a for loop. And so the syntax and everything should be familiar to you guys by now. So let's just get started. So first of all, outside the for loop, I'm going to declare a variable to store an factorial. And here I'm going to initialize it to 1, not 0. Why? Because n factorial is going to be constantly multiplied by some number. If I started out at 0, we know that 0 times anything is equal to 0. And so our end result is not going to be what we want. Now, if we start it to 1, it's guaranteed to update and eventually be equivalent to the value of n factorial. All right, so now let's write our for loop. So this for loop is basically going to iterate from numbers 1 to n, right? So here I'm going to initialize I at 1 instead, since that's where we want our for loop to start. And in this case, it matters more since we'll directly be multiplying I by n factorial. And then this for loop will run as long as I is less than or equal to n. All right, so now inside the for loop, all we have to do is update n factorial. And how we're going to do that is multiply it by I. And there we go, we're done. And now we can print our output. All right, so let's run this. Okay, be careful with your string concatenation. What I did there was I forgot to use the addition sign. All right, so let's say n is 6. Now, if we calculate 6 factorial, we should expect the output to say 720. And there we go, we get a nice little expression saying that 6 factorial equals 720. Let's try a bigger number. So now let's say n is 10. And I get 10 factorial equals 3,628,800. And we can really quickly verify this by searching it up. So here in the calculator, we have the exact same value. So yay, our program works perfectly fine. Okay. Now I'm going to comment out this for loop. And let's try and solve this problem using a while loop. So now, the factor we'll be multiplying n factorial by, we're going to declare it outside the while loop. And once again, we initialize it to 1. Then for my condition of the while loop, it's going to be while I is less than or equal to n. And then finally, I'm going to update n factorial by multiplying it by I, same as with the for loop right here on line 10. All right, and then we're not quite done yet, because remember that we are going to want to update this variable I here, since we use it for comparison in the condition for the while loop. So I'm going to increment it. And as you can see, side by side with the for and while loop, they really are similar. Declaration, same thing, except for a while loop, it's outside. And then condition right here in the statement. And then updating our variable, same thing as well, I++. All right, so by the end of the while loop, we'll have calculated and factorial. Now let's run this. So let me use the same example, 6. I have the same output as before, and let's try 10. Also the same output. So either method works. You may choose to use a for loop in some cases or a while loop in some cases, but just know that you can definitely use either of them and they will solve the problem in the same way. All right, so now we know how to calculate one individual factorial. Then let's expand that a little bit and then write a program that calculates the sum of 1 factorial to n factorial. So let's say n is 4, then what I would want to calculate is 1 factorial plus 2 factorial plus 3 factorial and then plus 4 factorial. The value of this would be my output. All right. So now I'm going to clear everything from our previous program. So first of all, we read an n. And here we're going to want a variable that stores the sum of 1 factorial all the way to n factorial. So let's call this fact sum, short for factorial sum. And here we're going to initialize it to 0. All right, then let's think about how we can break down this problem. So going back to my example of 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial. Well, the whole setup of this entire thing is kind of like a factorial, right? Because we're calculating the sum of factorials from 1 to n. But then for every factorial, we have another sort of micro problem where we're multiplying the numbers from 1 to n. So here, we know to calculate a factorial, we can use one loop. Then out here, when we're adding the sum of the factorials, this is also sort of a repetitive task, right? Because we're adding n factorials together. So we can take care of this addition with another for loop. In total, we're going to have 2 loops. One will be inside the other, so we're going to be using a nested loop. So this is going to be our solution to solve this problem using a nested loop. And while a for loop or a while loop will work for this, let's go with the for loop simply because the syntax is a bit more compact and easier to read and type out. So let's start with our outer for loop. So this outer for loop is going to tell us what number are we trying to calculate the factorial of, right? And this is going to run n times from 1 to n. All right. Now, within this outer for loop, we're going to declare a variable to store the factorial of I. Right, because I starts at 1, so first we want to calculate 1 factorial. Then we increment it, then I becomes 2, and we want to calculate 2 factorial, and so on, all the way until I reaches n, and then we calculate n factorial, and then we're adding all of them together. So I'm going to create a variable called I fact, short for I factorial. And inside this outer for loop, we're basically just going to plug in the loop we use to calculate the factorial of a number. So this loop is also going to run n times from 1 to n. In here, I'm going to update I factorial. All right. So by the end of this for loop, I'll have calculated the factorial of I. Then I'm going to go ahead and update fact sum. And I'm going to update that by adding the value of I fact to it. And so with this nested for loop, I'll have calculated the sum of the factorials from 1 to n. So for my output, the sum of factorials from 1 to n is fact sum. And we are done. Okay, let's run this. All right, so with the example I had just earlier from 1 factorial to 4 factorial, let's really quickly calculate the expected output. So this is equal to 1 plus 2 plus 6 plus 24. Adding this together, we get 33. Okay, So our output should hopefully return this. All right, so you might notice here that our output is actually wrong. We get 96. And the reason for this is that in our inner for loop, we let j run from 1 to n. However, with this for loop, we're trying to calculate I factorial. So j should run from 1 to I. And so this is a really common mistake that you should watch out for. After we fix this, our program should give us the correct output. All right, so as you can see, now we get the correct output, saying the sum of factorials from 1 to 4 is 33. Now let's try something a bit bigger. So let's just say I want 7 factorial. So that would be equal to all this. So 33 plus 5 factorial plus 6 factorial plus 7 factorial. This is equal to 33 plus 120 plus 720 plus 5,040. Now I'll spare you doing the addition, and that value is equal to 5,913. Okay, so now we can hit the enter button and see what happens. And there we go. Our output prints out the sum of factorials from 1 to 7 is 5,913. All right, hooray. All right, now I just want to modify this a little bit to calculate the product of 1 factorial all the way to n factorial. So rather than adding them, I want to multiply them like this. Okay. So first things first, we're going to want to change our variable here to fact product or something like that. And then we're going to want to change its initial value to 1 because then we're going to be multiplying it by numbers. Once again, if you initialize it to 0, it's going to stay stuck at 0 forever. All right, so let's take a look at our nested for loop now. So our outer for loop remains the same, 1 to n. I tells us the factorial that we want to calculate. And then we also calculate I factorial in the same way. Now here, when we update fact product, we're also going to multiply it by I fact. And then let's change our output here. So now it says the product of factorials from 1 to n is fact product. All right, so here, let's go ahead and run it. Now, using my example from 1 to n, say we multiply them. This would give us 1 times 2 times 6 times 24. Now, I'll spare you the math and tell you that this is equal to 288. So this would be what we expect from our output. So now if I go back and type in 4, hit enter, my output says the product of factorials from 1 to 4 is 288, which is correct. Let's try another number that's a bit bigger. Like, let's say I want up to 7 factorial. So that would be 288 times 5 times 6 times 7. And plugging this into the calculator really quick would give us 1, 2, 5, 4, it goes 1, 2, 5, 4, 1, 1, 3, 2, 8, 0, 0, 0. So as you can see, the numbers get big pretty quickly. Now, if we run this, let's see what happens. All right, so here you'll see we get a number that actually isn't anything like the answer. And this is because the product of factorials from 1 to 7 is way too big to store in an integer. So we have an overflow here. Now, if you want to fix this, you can change the data type of fact product to a long. Now, we haven't covered this ever before, but just know that long is basically like a longer version of an integer, so we can store much bigger numbers. Now here, let's run this. Now you can see that we're getting the correct integer, this really long thing. All right. So finally, let's flip things around literally and write a program that calculates the sum of 1 over 1 factorial to 1 over n factorial. So in other words, the reciprocals of 1 factorial all the way to n factorial. All right, so first of all, let's go ahead and modify a few things. So let's get rid of this fact product variable. We're going to replace it with a variable called fact sum, fact reciprocal sum. I've shortened it a lot here. So fact rec sum. All right. So our nested for loop is going to remain pretty much the same. we calculate I factorial, and then we want to update fact rec sum. So here we will be adding the reciprocal of I factorial. That means we're going to add 1 divided by I fact. Okay, then what we can do is print it out. So the sum of the reciprocals of factorials from 1 to n is fact rec sum. Okay, let's run this and see if it works. Let's just go with a really short and sweet example. Let's say n is 2. Then we're expecting 1 over 1 factorial plus 1 over 2 factorial, which is equal to 1 plus 1/2, which is equal to 1.5. But let's see if our program returns the same thing. Okay. The output we're getting is 1. Now take a few seconds and think about what we have learned sort of regarding division and data types, and think about what the issue possibly may be. Okay, if you thought of the issue here being integer division, then you were correct. But how can we fix that? All right, and if you thought of typecasting, then you're also correct. So we have an issue with our data types here. So first of all, our variable factor sum should not be an integer. It should be a double because it's going to store a decimal value. So let's go ahead and change that first. All right, now let's take a look at our for loops. So this calculation of I fact is going to remain the same. We haven't done anything wrong here. On line 14, though, we do have a problem. We're doing integer division here. And so remember, when we divide integers in Java, it basically truncates the decimal place. So when I had something like 1/2, which is really equal to 0.5, Java truncates the decimal, just leaves us with 0. So instead, what I was doing here when I was adding 1 over 1 factorial plus 1 over 2 factorial was 1 plus 0. And so I got 1 as a result. So now here we can typecast either 1 or I fact. I'm just going to typecast 1 since it's the numerator. And then we should have our problem fixed. So let's run this and test it. All right, as you can see now, I'm getting the correct output. So now I get 1.5. Now let's try another example. Let's say I'm calculating with 4. All right, so if I take 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial, This value gives me roughly 1.5 plus 0.166 plus 1/24 gives me about 1.7076. And so as you can see from our output, we get something roughly close. Now our answer is a little bit off since we did quite some estimation, but this is actually far more precise. So hooray, our program is successful. All right, so now let's wrap up this video. Thank you so much for watching this video, and I will see you guys next time. Bye.